Going on now to topic 2, we're going to be adding and subtracting fractions, radical expressions. First, when the denominators are the same, and then when the denominators are different. But to start us off, let's take a look at the vocabulary. Denominator, I think we know what that is. Least common denominator, least common multiple, and prime factorization. So some of these are pretty straightforward. Again, to add rational expressions, we must first write them with a common denominator. And the reason for that is going back to fractions a little bit. If you have one piece of these two, this is 1/2 of something. If you have one piece of this, this is 1/4 of something. So in order to get something that's equal or equivalent, you need to have this much. That would be 1/4 plus 1/4, which would be 2/4, which would be equal to 1/2. So we say in order to add these fractions, you need a common denominator, in this case of 4. And here, if you're just adding one of them, that would be 1/4. And here, this would then become 2/4. So that would be 3/4. Remember, we're not doing this one here. We're just adding 1/2 and 1/4. So in order to do that, you must have common denominators so that the ones have a representation of what they are reflecting and where they came from. Okay. In number 2, we talk about prime factorization. Well, we take 12 and divide it into its prime factors, and then the a to the third and b to the third, and this is what you get. Now for number 3, the least common multiple of the numbers 16x to the third and 18x to the second is 144x to the third. So how did we get that, by the way? Well, if we did the prime factorization of 16, we get our prime factors out here, and of 18, we get our prime factors out there. Now, as we look at these prime factors, what's the greatest number of times, let's say 2, is used in any one factorization? Well, it's used 1, 2, 3, 4 times. And well, the other factor is 3. What's the greatest number of times that a 3 is used in any one factorization? Well, it's used twice. So that's that. When we multiply these together, we get 144. So that's where we get our least common multiple. And it's similar to finding least common denominator as well. It's done in the same way. And then here we have to take the greatest power, which was x to the third. But now for this one, since we're dealing with denominators, the least common denominator of these two terms happens to be 60. And it would be done exactly the same way as least common multiple. What I want to do here is to show you strategy of doing it. Here we have the denominators are the same. So I'll put the x minus 1 right there. Now we just group like terms over it, which gives us a 4x minus 4. But notice we have to simplify if possible. So here we could take out a 4 and we get x minus 1. And in a sense, we could take out an x minus 1 from that. So we now have common factors. So our answer then is 4. Now this one's a little tricky, so watch how we do it. Our common denominators are already there. And notice we're going to make this a plus by making these opposite signs. So when you have a negative like that, what you have to do is change each of these signs and it becomes a plus. So this is 2a minus 5a gives me a negative 3a. A negative b and a positive 2b gives me a positive b. And for number 6, that is our answer. Now notice you can't cancel anything out. You can't cross out these a's or b's because this is a term. This is a term. You can only cancel out common factors. Now as you move into number 7, they're going to function notation and they want you to simplify and also list restrictions on the domain. Well, again, I told you we would use this again. So here, x cannot be what? A negative 5. Because if it was negative 5 here, it would be 0. And here, x cannot be what? A 0. So our domain is all real numbers, except x cannot be a negative 5 or a 0. Now let's get on to what we're doing, and we want to add these two terms when the denominators are not the same. So what will be my common denominator here? Well, it's going to be a combination of these two things, 2x and x plus 5. Now, in order to do that, I have to make this one an equivalent fraction by multiplying it by this part here. So I'll show you that. I'm going to multiply this part by 2x. And this one needs to be multiplied by this part. So I stopped it to see if it was going to be more complicated. It's just multiplying these two together and getting 14x squared. Then distributing this, 3x plus 15, and that's the answer. So this just goes right over here. If I had to combine like terms, I would have to, and eventually that's the answer. And remember, x cannot be negative 5 or 0. Alright, now for this next one, these are like terms. So I'm just going to put that there, and I'll make this a positive and make this a negative. So I now have 10 minus 6 is 4. But what are the restrictions here? Well, if we factor this into its conjugates, x plus 1, x minus 1 equals 0, we're going to say that x cannot equal a negative 1 or a positive 1. Those are our restrictions on the domain. All right, let's do number 9. Okay, to get a lowest common denominator, we're just going to have these two that we put together. But then this one, the 2, has to be multiplied by this, which is what I have there. The 9 needs to be multiplied by this. And then I distribute. I get this, combine like terms, end up with this. But then restrictions, here x cannot be a 0. And here this would factor into its conjugates, so a 5 and a negative 5. Otherwise, there are no restrictions. All right. Now, for number 10, this is very crucial. They're not using a lot of examples here, but you need to know this. When we try to find the least common denominator, we take the prime factors of 15, 3 and 5, 25, 5 and 5. Now the rule is, what's the greatest number of times that the 3 is used in any one factorization? Well, it's used once, so we need a 3. What's the greatest number of times the 5 is used in any one factorization? Well, it's used twice. So we need 2 5s, and I'm using my mouse to write here. And now, what's the greatest number of times the x is used in any one factorization? X to the 3rd. So, 3 times 25 is 75, x to the 3rd. Now, when you have trinomials or stuff like this, we have to factor them, which is what I've done. And this factors into its conjugates. Now, the same rules apply. What's the greatest number of times that x minus 3 is used in any one factorization? Well, here it's used once. There it's used once. So we just need one of them. What's the greatest number of times that x plus 8 is used in any one factorization? It's used once, so we need one. What's the greatest number of times that x plus 3 is used in any one factorization? It's used once. So our common denominator for number 11 is those that are underlined in blue. Now, for number 12. Now, notice the denominators are not exactly the same. But notice here, if I take out a negative 1 out of here, these reverse, and they are the same. So let me just show you that. If I have 9 minus t squared, and I factor out a negative 1 from that, I now get negative 9 plus t squared. And if I switch these around, I get t squared minus 9, which is what I have here. Just by changing the signs, taking out a negative 1. So I'm going to do that, and my new denominator now becomes t squared minus 9. But something happened here. There's a negative here when I did that. Now notice there's a negative there, and remember we could put a positive there and make that negative go up there. And what did we say a negative divided by a negative is? A positive. So we can get rid of these extra negative signs. That just becomes a positive. So what do we get then? Well, we now can just add them. T plus t is 2t a negative 8 plus 2 is a negative 6. And even though I could factor a 2 out of there, I want to. I just see it now here. So let's change colors. This is going to become 2, and this becomes t minus 3. Aha, interestingly. And this now will factor into its conjugates. I didn't think they were going to give us one so tricky right away. T plus 3, t minus 3. And now these cancel out. So our end answer is 2 over t plus 3. So some of these will be challenging. Notice we have a sign reversal. So that part wasn't too bad. But then we had to factor and simplify. At least they're not asking for what factors are eliminated and which denominator variables are eliminated out of the system here. For number 13, there was a negative there. So I moved the negative up there, made this a positive, and I get this. But I have a feeling that they made an error here somewhere. This is the difference of perfect cubes, and I would imagine something was supposed to cancel out here, but right now that's the answer, because these denominators are the same. We just had to do that little change of sign. Now, for this one, the denominators are different, so let me work that one for you. All right, let's do this one in stages here, because this gets to be quite a deal. So there's our original example in black. We need to find out our common denominator. So we factor this into its factors. Factor this into its factors. So what would my common denominator be? Well, I need one of those. This is repeated, but I only take the greatest number of times. And I also need this one and this one. So this is my lowest common denominator that I have up here. Now, this one needs what to make it this? Well, it needs this one. So I'm going to multiply this by that and 14 by that. This one needs this. Well, not a plus though, but it's a minus. Yeah, that would have messed me up, just that one little negative sign here. Of course, there's chances for other errors too. So what do? Well, we need to FOIL this and distribute this. So this part's easy. This is going to be 14m plus 14. Now I have to FOIL that. Okay, this is challenging. So when I FOILed this, I got this. Then I grouped like terms, and I got that. Now, interestingly, this can factor into that, but notice there are no common factors. So you could leave it this way, or if you factored it, you could have left it this way, but all over your common denominator that you could leave in factored form. One example takes a long time. All right, I'm not going to do all of them, but I'm going to try to show the strategy you would need to do them. So as you look at number 15, can you see that this and this are the conjugates of this? So the common denominator is this, and then this 2 would need to be multiplied by the conjugate, this. This doesn't change. And this 4 would need to be multiplied by the other conjugate. So once you distribute, you collect like terms, put it all over your common denominator. Simplify if you can. In number 16, again, it's the difference of perfect squares. It will factor into its conjugates this, and I believe I got the wrong one there. Yes, this is x plus y, so the conjugate of this would be x minus y to make it this. So here this is going to be a binomial that we're going to square, but then we have to change the signs. So in fact, let me do this one then. So I'm going to move this over here by foiling this. I get this here. Change each of the signs as I take away the parentheses. Combine like terms. These are like terms. Put it in some sort of order. And this is all over this then. And that is your answer. So you will find in doing these examples in Chapter 6 that they're rather tedious, in that just the slightest little wrong sign somewhere will mess you up. So slow, cautious. You want to know the technique, of course. And, you know, on your test you probably won't be getting any that are too difficult. Okay, the others are similar. And again, watch your signs. What's your common denominator? You have to have equivalent fractions. Let's take a look at number 21. This will be our last example. Now we have to also list restrictions here as well. So restrictions here, x cannot be a 1. Here x cannot be a 1 or a negative 1. Just the conjugates. So let's work on this. What's my common denominator? Well, actually it'll be this one. Nope, didn't come out. This one right here. So let's work it. Okay. So our common denominator is this that I put into factored form. Now our 3 needs all of it. So I'm going to multiply the 3 by the common denominator in its product form. Then this one needs x plus 1. This one doesn't need any. So I distributed, got this, group like terms, and got this over this. Now I notice that this could factor. It factors into this. And now what happens? Well, we have a common factor. Wow. So for closure, this is a good one. We're using a lot of stuff, and we're just at 24 minutes. Again, slow and easy. Double check your work.